Good day everyone, I am Gerald Tao from Group 4. I'm here to discuss about the important phases of hydrologic cycle. Measurement in gauge and network, radar and satellite estimate. So the hydraulic cycle is important because it is how water reaches plants, animals and us. Besides providing people, animals and plants with water, it also moves things like nutrients, pathogens, and sediments in out of aquatic ecosystem. So, water cycle is also called as hydrologic cycle that involves the continuous circulation of water in the Earth atmosphere system. So, of many processes involved in the water cycle, the most important are evaporation, transpiration, condensation, precipitation, and then up. So later on, you will know about the instrument that used in measuring rainfall, detecting weather, and etc. So gauge networks. Installing a rain gauge at a strategic location on the landscape is the most simplest approach to track precipitation. So almost all rain gauge have a panel that funnel water down to a fanning and then into a collection container. So the amount of water in the container is either monitored or predetermined intervals or measured and recorded automatically. We can relate the volume or depth of water in the container to the amount of rainfall if we know the size of the top of the panel in relation to the size of the collection container. So, knowing the size at the top of the panel relatively to the size of the collection container, let us related the volume or depth of water in container about the rainfall. So here's what's called standard rain gauge. So the standard instrument for the measurement of rainfall is the 203 millimeter or 8 inches rain gauge. So this is essentially circular funnel with a diameter of 203 millimeter, which collect the rain into graduated calibrated cylinder. So the measuring cylinder can record up to 25 millimeter precipitation. So the answer is often to metal cylinder with a panel on the top and a plastic measuring tube in the center. So before overflowing in the bigger outer cylinder, the measuring tube can handle up to 2 inches of rain. The observer removes the panel in the inner tube during the winter and leaves the snow to collect in the outer tube. So after melting the snow out and measuring it, the observer can provide a accurate water equivalent. So because someone has to walk outdoors and physically monitor the water level in the gauge, it's difficult to collect legally or sub-daily. So rainfall data using this rain gauge, so the enter the rain gauge for recording. So next is the radar and satellite estimate. So under it, the ground-based weather radar. So it is the first appeared during World War II and have been used to monitor precipitation primarily over land. Radars on the ground fire microwaves pulsed in narrow beams that can scan a circular pattern. When a microwave pulse collides with precipitation particles in the atmosphere, the energy is dispersed in all direction. So with some if it returning to the radar intensity high precipitation type rain, snow or hail, and the motion are also all estimated using these measurements. Due to vast gaps between monitoring location and the land and huge gaps over the ocean, obtaining continuous observation of precipitation using ground-based system or rain gauge and radar system, it is a problem. So, obtaining continuous measurement of precipitation from ground-based system, its present challenge due to large gap between monitoring sites land, huge gap over the ocean. So here's what called ground-based weather radar. So ground-based weather radar have been used to observe precipitation mostly over land. Ground-based radar sent out pulse of microwave energy in narrow beams that scan in circular pattern. So, weather is the most accurate source of weather forecasts and warnings in the world, recognized in a new proof of performance result. So, weather radar range from $300,000 to $350,000 on the low end of well excess of $1 million for the highest end in dual polarity systems such as WQYT has, according to Chris Good, so Vice President of Sales and Marketing of Enterprising Electronics Corp. So next is Earth observing satellites. At the global scale, Earth observing satellites can offer frequent estimated of precipitation. Satellites equipment with instruments designed to study certain atmospheric features such as cloud temperature and precipitation particles, sometimes known as hydrometeors, are used to accomplish this. So these data are particularly valuable for filling in data gaps between rain gauge and ground-based radar station, as well as providing information on when or where and how much precipitation is falling around the planet. Satellite data also offer a distinct perspective. Satellite equipment evaluate the quantity of electromagnetic radiation or energy emitted and reflected either from the top or clouds from the rain droplets themselves. So offering a top-down picture, even the three-dimensional structure of the precipitation can be observed using space-borne radar device. Scientists can discern between rain, snow, and other types of precipitation using satellite measurements, as well as observe the structure, intensity, and dynamics of storm. So swarm radar instrument can even observe the three-dimensional structure of precipitation. So this data is extremely useful to filling data gaps of extent between rain gauge and other ground-based radar system. So it is very important. So here's the Earth observing satellites. So satellites help us to monitor and protect our environment, manage our resources, respond to global humanitarian disaster, and able to sustain development. So they provide essential information on the vast number of areas, including ocean salinity, ice thickness, crop health, and air quality. So why are satellites important? So the bird's eye view that satellites have allow them to see large areas of Earth at one time. So this ability means satellites can collect more data more quickly than instruments on the ground. So satellites also can see into space better than telescope on the Earth's surface. And that's all. Thank you.